Okay. Oh my God. Okay, thank you. Hi, I'm Orange, and it's my pleasure to become a speaker at SecT. And the next session I'm going to talk is the research about the attack service I discovered in Apache HTTP Server. So first, I want to ask, is there anyone here who hasn't heard of the Apache HTTP Server before? If so, please raise your hand. Wow, almost all people have heard of that. I believe I can skip the introduction. Let's still give you a quick overview. So first, Apache is an open source project that's nearly 30 years old. So it might be older than some of you here, maybe. And because Apache has existed since the early days of the internet, it has accumulated a lot of technical debt. Also, Apache enabled the CGI by default, which greatly increased its potential attack surface. And the last is that Apache is the only web server that can integrate with PHP smoothly. So since Apache and PHP were born almost in the same year, in the early years, Apache was the only choice to use PHP. And PHP also made several customizations for Apache. So nowadays, there are a lot of ways to configure a PHP environment. For example, there are over 6 different modules just for the fast CGI protocol. And each module has different syntax. An interesting thing is that among these directives, some not only look very similar, but also have identical usages. So if a website admin did not understand the intention behind each directive, it's easy to make mistakes and create security issues. For example, when a website admin wants to set up a PHP on his machine, he might come across 2 common directives, add handler and add type. And which one do you think is correct? Actually, both are correct. Both methods can probably get the PHP running. So does this mean both are all good? Firstly, being correct does not mean being safe. And under certain conditions, add type has been proven to be vulnerable and allows the attackers to disclose the PHP source code remotely. And we will discuss this detail later. And the last thing I want to highlight is, from my years working in offensive security, I find that websites who use Apache tend to have the messy environment. In practice, many Apache servers are hosting a lot of third-party applications, such as the Tomcat and Nginx locally. They would love to use the rewrite rule to dispatch the request to the applications. And the file system on the server is also a mess, with a lot of strange files sitting on the web root. So today, our mission is to break this type of Apache HTTP server, to identify such vulnerable servers and learn how to break them all. Before we dive into our topic, let me introduce myself. Hi, I'm Orange. And currently, I'm the principal security researcher at DevCore. I have spoken at several hacking conferences, and my research also got several honors, such as the Pong-to-Wong Champion and the Ponging Awards. So why do we focus on Apache? At the beginning of this year, I started to explore some high-impact open-source projects. And while closely reviewing the Apache source, I smelled something bad in its coding style. First, Apache is comprised of over 100 of small modules. The source code includes 136 modules, and about half of them are either enabled by default or commonly used by web servers. What's even more surprising is that these modules also share a very large structure while working together. These structures include all the elements needed while handling a HTTP request. All modules rely on this big structure to synchronize, communicate, and even exchange data. A HTTP request will pass through several phases. Modules are like playing the basketball, passing the structure from one to another. This type of collaboration is not new from the perspective of software engineering. Each module simply focuses on its own task. As long as everyone has done its work, the client can enjoy the services provided by the Apache HTTP server. However, any module can update the structure at any time. So this approach might work well with a few modules. But when there are over hundreds of modules today, without any good standard or guideline, can they still work well together? So our research focused on the relationship and interactions between these modules. Each module might be implemented by different people and subjected to years of iterations and code refactors. Do they still know what they are doing? Even if they understand what they are doing, how about other modules implementation detail? They have to work together. But today, if a module accidentally modifies the field it considers unimportant, but is crucial to another module, it could affect the latter's decision. Also, if there is any misunderstanding on any field within this structure, it can create security issues as well. So from this starting point, we create 3 different types of attacks. And because all of them are more or less related to the misuse of the structure, we name this attack confusion attack. And the following are the attacks we have so far: the file name confusion, document load confusion, and the handler confusion. As this is the completely new attack service, the first person who delves into, of course, can find the most bugs easily. So this attack service also made me the person who currently holding the most vulnerability from Apache HTTP Server. Yeah. Thank you. Additionally, because these vulnerabilities are based on legacy architectural issues, so most of the patches are not backward compatible. Updating your Apache to the latest version might break old configurations. So for many production servers, simply apply the update is not a good idea. OK, let's go to our attacks. First, I would like to introduce the attack called file name confusion. This attack occurs when different modules handle the file name using different standards. Literally, the field file name should represent a file system path. However, some modules treat it as a URL. So if we send a HTTP request, some modules consider the field as a path, but some other are not. The inconsistency between these modules will create security issues. The first, oops, oh my God. OK, so which module consider the file name as the URL first? I think, OK, the first is the rewrite module. This module allows the website admin to redirect a request to any file or URL. I believe this is by design for maybe user experience. However, this design also introduced certain issues. For example, even if the destination is a file system path, the rewrite module will treat all the results as a URL. For example, if a website admin sets the following rule to target the username right after the path /orange/ to open the corresponding profile. So when you access the /user/orange, Apache will open and print the content, print the file content of the /var/user/orange profile YAML. However, what if you add one more question mark today? %3f is the URL encoded format for the question mark. So in the time of the name translation, the rewrite module will first process the rule to get the corresponding destination, just like the path in the slides. However, we said that rewrite module will treat all the destination as a URL. So the module then split out the query string by the question mark. So here is a path transaction. And this is our first primitive. You can use a question mark to truncate the rest of the path. For example, here we use this truncation to access the secret file we can't access originally. For here, let's pause a little bit about the exploitation. Also, it might look like a minor issue for now, but please remember it because we will use this primitive in the later attacks again and again. Let's move to the next primitive. So which module else also consider the file name as a URL? So does the proxy module. At the first glance, this seems to make sense because the purpose of a proxy is to redirect the request to other URL. So when we consider this behavior on its own, it doesn't appear to be a problem. However, if your web server relied on the file-based access control, it can be risky. For example, here is a common password-protected configuration using the files directive to prevent unauthorized users from accessing admin.php. And this type of authentication can be bypassed when the server is running on the PHP FPN. Imagine the scenario when you are visiting this URL today, the admin.php, %3f, and overall.php. First, in the time of the HTTP lifecycle, the authentication module will compare your requested file name with the protected one. At this point, your file name is admin.php :OOO.php, which is totally different from admin.php. So Apache didn't think you need the authentication. However, to support various protocols like HTTP or FTP, the proxy module will rewrite the file name into the following format and use it as the file name and send to the backend PHP service. Since the file name is in a strange format, so the PHP also introduced some workarounds to adapt this behavior. The PHP will normalize this unusual file name first and spread it by the question mark to get the original file name for further processing. So the original authentication required area can be bypassed with just a single question mark. Of course, it's not just admin.php. There are more risky configurations can be found all over the world, such as the PHP info that is accessible locally, and the adminer, which is blocked by default. All of these protections can be bypassed by just a single question mark. OK, this is our first attack, playing the inconsistency between the authentication and the proxy module. And ready for the next? The next attack we are diving into is the confusion based on the document root. First, this is a common configuration the Apache server would have to hide the file extension from the URL. So when you visit the URL, the server/html/about, what file do you think the Apache will actually open? Is it about.html under the root folder, or the file from the document root at /var/www/html? If you think it's the first one, please raise your hand. If you think it's the second one, please raise your hand. Wow, OK. OK, the answer is it opened both. Magic, right? This is also what our second confusion is talking about. For any given rewrite rule, the Apache always try to open both the past version with and without document root. Oops. This allows us to intentionally access the files outside the web root, especially the root folder. So you might be wondering, hey, does this mean we can access the /etc/password? Yes, but not entirely. technically, the server indeed accesses the password file. However, the server's built-in ACL blocks our access. You can see the default configuration denied all. But the interesting thing is the built-in ACL by default allows the access to the folder /user/share. And thanks to this configuration, now we have a limited arbitrary file access on Apache HTTP Server. For example, we can access the documentation under /user/share to learn how to use the SSH. And however, now we can only access the files with the extension .html. So you might ask, can we access the file outside that? I'm not sure if you remember the primitive we have earlier. We can combine them together using a question mark to truncate the extension. So theoretically, as long as we can control the prefix of the rewrite rule, we can access the entire /user/share. This is a blast. Even the tutorial from the official Apache website has problematic examples. OK, now we know the root cause. And what can we do next? First, we can disclose server-side source code. Since the Apache decides whether to execute a script or not based on the current virtual host. So accessing the full path through a virtual host that doesn't support PHP can easily explore its source code. And since we have broken the trust of the document root, the entire /user/share has now become our playground. So the next step is to find out what files we can leverage. Actually, there are a lot of files we can leverage, such as the existing tutorial, the unit test files, and even packages from the programming language can become our gadgets. So the first gadget we are going to demonstrate is abusing the library office, which is installed by default on the Ubuntu desktop. We can leverage the language switch feature in the help files to achieve accesses. Or we can disclose sensitive information. For example, if you install the WebSocket daemon, the daemon will, by default, include a PHP script called dumpenv.php. You can directly access this example file to leak sensitive information. And additionally, if the target installs a service like the Nginx or JT, the default web root is also located on the /user/share. You can download application configurations such as the web.xml easily by a simple rewrite rule. Here we can execute the PHP info by the package devcal to leak sensitive information. And more interesting is even some PHP or front-end packages, their tutorials or debug console can be leveraged as well. For example, here are some gadgets from the jQuery, MacPy, and JPGraph. Here we use the tutorial from the jQuery feed to read arbitrary file content. So for now, you can see the possibilities of this primitive. There are endless local gadgets, and all the remaining is to find more powerful and universal gadgets. But it still seems a little bit not perfect. And you might be curious about that. Can we jump out of the /user/share? Yes, of course we can. Yeah, thank you. So that brings out to our third primitive, to jailbreak from the /user/share. Apache, by default, follows the symbolic links. So we can leverage this feature to jump out of the /user/share. So any package that has symbolic links can now become the stepping stone to access more gadgets for further exploitation. Here we list some useful gadgets we have so far. You can read the cacti logs, the server configuration, or even access the user upload files on Redmine. Here we demonstrate a Redmine RCE through double jumps. Under the Redmine folder, there's an instance folder that can jump to /var/lib. And within the directory, the config folder can also jump to the /etc/Redmine, which contains Redmine's database configuration and the secret key. So by using an unsafe rewrite rule, we can access the secret key by two symbolic links. Since Redmine is a Ruby on Rails application, the content of the secret key is actually the key for signing and encryption. So the next step should be easy: embedding malicious objects to the cookie, signing and encrypting with the known key, and then get code execution through the server-side deserialization. Okay, the last attack I'm going to introduce is the confusion based on the handler. So back to our initial questions. Why can both directives, one for adding a handler and one for adding a type, can get the PHP running properly? This is actually due to a legacy conversion in Apache, or you can say it's part of its technical debt. Before the Apache enter the main handler, if the handler field is empty, Apache will take the value from the content type as its handler. So our third attack is all playing this behavior. Sometimes the content type can be converted into the handler in Apache HTTP Server. So how it could be wrong? Let's give you something fun first. Imagine that your server is running PHP using add type. It's very common to see in the PHP applications. And now you are accessing the file config.php. Normally, since the file extension is .php, Apache will assign the corresponding value to the content type based on your add type configuration. And later, PHP will then know, oh, it's his responsibility to handle this request. The normal process is good because the handler is empty. So before entering the main handler, the legacy conversion we mentioned earlier will convert the content type into the handler. So that explains why both add type and add handler are the same. However, what if there is any other module overrides the content type by accident? For example, by triggering a filter error in mode security. When there's an error, the mode security will think, oh, I made some mistakes, so I want to send out some error message. And since the error message is in HTML format, it also sets the content type to the HTML. And the configuration file, which is supposed to be executed as a PHP, is treated as a plain HTML now, exposing all the sensitive content outside. So this is our first primitive for handler confusion, disclosing any PHP source code by overwriting the content type. And if we think this vulnerability deeper, the nature of this vulnerability is actually caused by there are no clear guidelines for the use of the content type. It can be set by configuration during the request or used as the content type header in the server response. While using this field, the Apache cannot distinguish which one it is. So following this idea, if we can control the content type, we can invoke arbitrary handler, right? So is this right? It's very promising. However, the situation is not as simple as it seems. In practice, all the code paths that can modify the content type are all after the legacy conversion. So even if we can modify the content type through the server responses, it's useless because it's too late. So what else can we do? No worry, we code the RFC to save us. RFC 3875 is the specification for the CGI. And the section 6.2.2 introduced the local redirect response. The mechanism works like this. If the CGI returns the status of 200 and include a location header, the Apache will treat this location as an internal server-side redirection. And the server-side redirection will first open a new HTTP lifecycle and copy the original content type to this new request. For example, if you control the response header through, of a CGI, that means you can control the whole content type and the status code. So when Apache sees, oh, the status is 200, it performs the server-side redirection to start a new HTTP lifecycle. In this new request, the legacy conversion we mentioned earlier will copy the file, the content type we provided into the handler, that giving us the ability to code arbitrary handler. So this is our second primitive, arbitrary handler invocation. Basically, the entire CGI family follows this feature, including but not limited to WSGI, fast CGI, and UWSGI. As for how to trigger this server-side redirection, here we provide two scenarios. One is a CRF injection, and other is a SSRF that can control the response header. Here we use the CRLF as our example. In the normal case, a CRLF injection in the HTTP header will be treated as XSS because there's no other server-side processing. However, today, you can override the content type to a name called server status. Then you can leak sensitive information that should only be accessible from localhost. You can also easily transform arbitrary files into your PHP backdoors by overriding the handler to the PHP module. You can even achieve SSRF through the proxy module. And this SSRF allows you to control the request headers and read all the response. And it's very beautiful that this SSRF can also access the local Unix domain socket. All thanks to the convenience feature brought by the proxy module. And lastly, let's demonstrate how to turn this SSRF into RCE. Here we used a common trick in CTF. The official PHP Docker image by default comes with the peer, a PHP extension manager, and the peer CMD is the entry point for the package manager. We can leverage the SSRF to access the package manager to do further exploitation. For example, we exploit a command injection in the run test command. And we can get reverse shelled easily. So today, you have learned a new way to exploit the CRLF injection. So please do not report the header-based CRLF injection as an XSS again. It's really a waste. Yeah, this type of bugs has the potential to become the RCE. Okay, here my presentation is nearly coming to the end. But before closing that, I would like to say, maintain open source is really challenging, especially keeping a project for 30 years. You have to make it convenient for the end users and compatible with all versions. The entire development process is built upon a pile of legacy code and technical debt. So if there are any Apache developers in the audience today, I want to say thank you. Okay, let's give you some short takeaways. Today we have introduced, first, the question mark is a powerful tool that can truncate arbitrary paths or bypass the authentication. And the rewrite rule contains a hidden trap to let you access the system root. And lastly, by controlling the response headers, you have the ability to invoke arbitrary handler through the Apache legacy conversion. There are also some future works. For example, different distributions have different configurations, such as the OpenBSD, FreeBSD, or even on-premise applications. They could have more allow by default ACLs, more local gauges, or more symbolic links. And finally, in the real world, you can imagine there must be numberless rewrite rules to figure out ACLs to be bypassed and hidden CGI out there. So applying all the technicals we had today is now your mission. So this is the end of my presentation. So if you have any questions, here's my contact information. And thank you for being here today. Thanks.